Hello everybody, a little bit different from other years, but welcome to FOSDEM. I'm going to give you a presentation for about an hour, I hope, and we're going to see where we wind up at the end. So, sets without borders, set operations in the Raku Programming Language. But what is the Raku Programming Language anyway? So let's go back a little bit. It started live in 2000 as the next version of Perl, Perl 5 at the time, and Perl 5 still at the moment. It became Perl 6, it became actually a sister language in 2008. Sister language, yeah, what is a sister language? That was really unclear. So anyway, the first official release was announced at FOSDEM 2015, so that's 6 years ago now. And we got a first release at Christmas 2015, and we was renamed to Raku in 2019. So please use the new name Raku nowadays instead of Perl 6. Everybody will be happier for it. So what was my involvement in the project? In 2000 I happened to be at the announcers meeting, which was just an accident really, but it was great to be there. In 2005, I wrote some specifications for the language at the time, which fortunately did not get implemented. I got involved again from 2012, initially for documentation only, but from 2013 onwards, I became a core developer. And from 2015 onwards, I've been writing a weekly blog. So what are the concepts that we're going to cover here in this presentation? We're going to cover classes and objects. We're going to talk about what QuantHashes are, sets, bags, and more. The function of the which method, yeah, that's which in capitals. We're going to discuss what an object type is and what a value type is. And we're going to see some other assorted Raku features along the way. So why would I actually do this presentation about set operators? The thing is that I think that a lot of people don't know about set operators, so unknown means unloved. They don't know about sets and friends. Basically, coming from other programming languages, particularly Perl, people are used to using generic hashes instead. They don't know sets and friends for the handy additional functionality that they can offer. So, yeah, that's the reason basically. And when people do find out about set operators, they basically, okay, they found sets and you can have set operators, but it's separated from the normal flow of a program. And the thing is that most people don't realize that the set semantics are fully integrated into the language. So when you actually use set semantics, you can allow for much more descriptive programming, which I think is a good thing. So, let's start on this journey, shall we? So, everything in Raku is an object. Everything in Raku is an object. Let's repeat that. Everything in Raku is an object. But what is an object anyway? I mean, how can I create an object? Or how can I create a new type of object? Well, in Raku, it's all a matter of class. And so let's look at the Wikipedia definition of classes. What is a class? In object-oriented programming, a class is an extensible program code template for creating objects, providing initial values for state attributes, and implementations of behavior methods. Well, sort of adapted from Wikipedia. In Raku, the class name is used as the name for the class, the template itself, new for the default structure of the class, which is a method that creates objects. So again, adapted. So let's have a look at some code, shall we? There we go. We have a class, and in this case we're going to give it the name point, and then we have some curlies where you can expect stuff to happen in between. That's all there is to create a class. That's just it. It's a fully functional class. You can create objects with it. You can't do much with it, but yeah, it'll need more stuff for that. So, creating objects. Let's look at the definition from Wikipedia again. When an object is created by a constructor of the class, the resulting object is called an instance of the class, and the member variables specified to the object are called attributes in Raku. Attributes in Raku are specified with the has keyword. So let's add them, right? Has x and has y. It's a point. It's a two-dimensional space point. And basically we have an x and a y. The dollar means that it's a singular value. And the dot means that it's actually a public attribute. So what do we do to create a new point object? We basically create a variable to put it into. We basically call the new method on the point class, tell it which value to use for x and which value to use for y. And then we can actually call the methods on the object. In this case, we call the x, we say the method, we call the x and the y method, and we actually get a result 42 and 66. That's all there is to it, to create a point class that has an x and a y. And it takes an x and a y value and basically stores it for you. So, coming from other languages, why would you not just use a hash for this? I mean, in Raku I would say, why would you? Because in Raku it's not faster than using an object. In fact, it's slower, as I will show. In Raku it takes about the same amount of memory. And what's worse, hashes do not protect you from typos. And an object can actually provide better error feedback, which I'll show you in a minute. So let's create a point by just using a hash. So we create a hash, we put an x and a y into it. And if we want to say the values, we actually have to index into them with x and y, and we get the values. Yay, it works. That's not so difficult, is it? Yeah, well, it's slightly more typing, as you can see. So yeah, maybe not so nice. But anyway, so let's have a look at this again. See the difference? Well, let's run this. What do we get? Ooh, silent nothingness. Why? Because I used an uppercase X instead of a lowercase x. Nobody complained. Well, yeah, the uppercase X just didn't exist inside the hash, so you didn't get anything. Now, if you compare that to using a class and try to use the uppercase X method on the object, you get a much more valuable error response. So, how does it go with speed? Here we have an example. We create 1,000,000 point objects and we create 1,000,000 hashes with parameters in it. As you can see, creating the point is slightly more writing than creating the hash, but not a lot. And yeah, as you can see, it is much slower to actually use the hash. Compare the real time of these creating 1,000,000 of these objects and hashes, you can see that the objects are about 6 times as fast as using a hash. So if we just basically look at this again, using classes is faster and gives you better error reporting when you do something wrong. So why not use objects, right? So finally coming to the bit of the presentation that we were actually going to talk about. What is a set? So we look at Wikipedia again and basically adapt it a little bit. In Raku, a set is a well-defined collection of distinct objects, considered as an object in its own right. For example, the numbers 2, 4, and 6 are distinct objects when considered separately, but when they are considered collectively, they form a single set of size 3, written as set (parenthesis open) 2, 4, 6, parenthesis close. So how does that look in Raku? Well, exactly like that. We create a variable and we basically create a set. Just like that. It's almost magic. So what do we see when we actually say the variable that contains a set? Well, there's a representation of it. We call it a gist. And it shows you that it's a set that has 2, 4, and 6 as values in it. And it acts as a hash, so you can actually index into it. You can ask it, do you have the value 2? And that's true. And do you have the value 7? It doesn't, so that's false. Now let's create a set with some more elements, like 2 times 2 and 3 times 6. Because in a set, each value can only occur once. The resulting set just contains the 2, the 4, and the 6. Again, of course, you can ask if it's true for 2, and 7 gives you false, as expected. So, what is a bag? Again, we look at Wikipedia, and actually the way bags are named are a little bit different everywhere. So in Raku, a bag is a modification of the concept of a set that, unlike a set, allows for multiple instances for each of its elements. The positive integer number of instances given for each element is called the integer weight of this element in the bag. So how does that look? Well, let's create a list of letters where A happens once, B happens twice, C happens 3 times, and D happens 4 times. That's a lot of quoting and a lot of stuff going on there. Fortunately, in Raku we have a shorter way of saying this using the pointy brackets. So pointy brackets, you get basically is a short way of saying quote everything inside here divided by white space. So we can easily create a bag with that. And then, so put it in the variable, create the bag. And basically if we want to say the bag, it gives you a representation showing that the B happens twice, the C happens 3 times, and the D happens 4 times. So if you ask for the C in there, and note we can actually use the pointy brackets there as well for easy and convenience. It tells you it's 3, and if we ask for the number of times that E is in there, it gives you 0. So okay, now that's clear. Now we need to actually move on to the different types of objects that we have, and one of them is the object type. So what is an object type? Nothing in Wikipedia about that, so actually we have to define it ourselves. In Raku, a class is said to be an object type if the attributes of an object of such a class may be changed after having been created. So it publishes its object identity by returning a unique object when the which method is called on the object. This is the default when creating classes. Every object of an object type class is unique, even if the corresponding attributes of 2 objects all have the same value. So let's go back to our point class. There we have it again. We changed it a little bit to actually provide a default value for x and y. So if you do not specify an x and y when you create a point object, it will assume that they are 0. The reason I did this to make the code a little shorter, so I don't actually have to specify the x and y every time I create a point object. So what does the which method on a point object actually say? Well, it gives the string point and some number. And I create another one, and I create another one. And if you look carefully, you see that all the numbers are different. That's because, well, in this case, by default, classes in Raku are object types. And object types, every object in Raku then has a different identity. So what happens if I actually create 10 points in a set? Note the XX here is a short way of basically doing something 10 times. So this basically creates a list of 10 points. And from there I create a set. And then I ask for the number of elements in it. Like hashes and lists, you can ask for the number of elements in it. And because of all of them being different, there are 10 elements in this set. All different points with the same value. That's why we also have value types in Raku. So what is a value type? In Raku, a class is said to be a value type if the attributes of an object of such a class will not be changed after having been created. It publishes its object identity by returning a unique value object when the which method is called on the object. Every object of a value type class is interchangeable with any other object of which corresponding attributes all have the same value. So, how does that work? Well, let's go back to our point class. There we go again. We need to add a which method. So we write a method which doesn't take any parameters, hence the parentheses with nothing in between them. We create a value object add object with the value object new, and we give it a string. Note here that the $.x and the $.y are basically short for calling the methods x and y on the object. So basically what we're creating here is a very nice way of saying this is a point 0, 0. So what happens if we do this again? Well, we get 0.00 because x and y are both 0. And we do it again and we get a 0, 0 again. So you note that they're all the same. So when we actually create 10 of these points and put them into a set and ask for the number of elements, we actually get 1. Because they're all the same, they all have the same value type. Now, writing the which method can be a little bit of a pain. It's a bit of a boilerplate. So actually there's a module in the ecosystem. It's called valueType. And you can actually just say does valueType and it will do the right thing for you. So there you go. So what is a QuantHash? Well, in Raku, a QuantHash is the general term that comprises the immutable set, bag, and mix classes, and the mutable counterparts set hash, bag hash, and mix hash. Quite a mouthful. It refers to the fact that they act as a hash, but that the values are in some way quantified. Also, a key in a QuantHash is the actual object, not a stringification of the object. In that sense, they're similar to object hashes. Otherwise, a QuantHash has all the normal hash methods such as keys, values, pairs, KV, sort, etc., etc., etc. That's why it's a hash, QuantHash, of course. So what types of quantification do we have? For set and set hash, the values can only be a boolean, so either true or false. For bag and bag hash, the value, aka weight, can only be an unsigned integer, so 0 or more. And for mix and mix hash, the value, aka weight, can be any real value, so also negative. What negative values mean? Well, that's basically depending on how you're going to use that. Yeah, there's some pretty screwed up things you can do with it, but let's not go into that right now here. So here we go with creating a set again. Oh, and by the way, of course, you can actually tell the hash that it is a set. This is the syntax that you can use. So if you basically want to use %s for your accesses to sets and set hashes and mixes and bags and everything, you can basically tell the hash that it is to work like a set or a bag or whatever. So basically it all works the same from here. Well, let's go back. Okay, it basically works the same here. So you can basically just use %s as before. And you should note, of course, that if you use the pointy brackets, you actually are using a string in there. And the string to is not the same as the value, the integer value to. So be careful with that. So finally, we're getting to the operators. So set operators are those operators that apply set, or more accurately QuantHash semantics, on their operands, which basically means they work on the which of the operands where applicable. They either return a Boolean value or an appropriately proportioned QuantHash. The operands of the set operators do not have to be QuantHashes. Operands will be automatically coerced to the appropriate QuantHash if needed. Note the if needed here. In the worst case, they will get coerced completely, which may be a lot of work. But in many cases, the set operators can actually figure out more intelligently whether something is going to work or not. And so by not creating the QuantHashes with the set operators, you can actually save a lot of work. So let's have a look at some of these operators. First of all, the identity operator. The simplest way to type it is 3 equal signs in a row. And there's actually not a Unicode version of this. It's basically because it's one of the oldest operators in the implementation of Raku. And in those days, nobody decided to actually create a Unicode version for it. And now we're stuck with it, so here we go. So basically, what does it do? Basically, the question asks, is the item on the left the same as on the right using set semantics? And it returns a Boolean. So how does that work? Well, let's have a look here. So we're assigning the integer value 42 to $A. We are assigning the string 42 to $B. We string compare A and B, and it's true. Why? Because the integer 42 gets coerced to string by the equal operator. If we numerically compare A and B, it's also true, because the string 42 gets coerced to a number, and thus becomes the same as 42 as the number. Now, if we use the triple equal sign, we basically look at it in set semantics. And in this case, A and B are not the same because they have a different which. How does the switch look like? Well, they look like this. Int pipe 42 and str pipe 42. The use of the pipes in this case is basically how most of the implementations use this. You are completely free in basically defining what string you're going to use, as long as you can make sure that for each object that is supposed to be a value type, the string is unique, so that we don't get any false duplications. Next one I'm going to cover is the set equality. The simplest way to type it is parens open equal equal parens close. This also has a Unicode version that's more mathematically recognizable, which is 3 dashes on top of each other, which actually is according to the Unicode database, considered the name to be identical to. And the question that it asks basically, are all the items on the left the same as all the items on the right? And this returns a Boolean. So let's create two arrays. An array A with 1, 2, 3 in it, and array B with 3, 2, 1, 2, 3 in it. As you can see, they are clearly not the same. Now, most people that don't know really set operators might think that it would be a good idea to actually create sets of these. So let's, for the argument, just follow this here. And so we actually compare the two sets, and it will return true. But you don't need to actually convert them to sets, because if you just use the set equality operator on the two arrays, you also get true. So there's no need to do this. So how could this be faster? Well, the thing is, with the set equality operator, the number of elements on either side must be the same. And yeah, well, and as you clearly can see, they are not the same, but they would be the same if they are sets. So that's why this works. Another set operator is the isElementOf. Basically, anytime you want to find something in something else and see if it actually exists in there, you can use the isElementOf. The simplest way to type it is elem between parens. It also has a Unicode version, which is more mathematically recognizable, which is called elementOf according to the Unicode database. And basically, it asks the question, is the item on the left an element of the right? And this returns a Boolean. So let's look at this. We create an array with letters, and basically we can ask, is the A an element of the array? It's true. And we can do the same for E, and it's false because it's not in there. Now, here it can short circuit, because as soon as one of the elements in the array actually matches, it can return true. It doesn't have to check the whole array. Now, if you would actually have coerced this to a set before actually doing the elem, then it would have to actually look at each of the elements in the array. Now, in this case, the first one is already a hit, so it will only look at the first one. Supposedly, if you're looking at the D, it will actually check a lot of them, but still would finish before the end. So that's why you actually don't want to actually coerce two sets in this case. Another set operator is subsetOf. The simplest way to type this is parens open, smaller than, equal, parens close. More mathematically recognizable, we have a character for it called subset or equal to. Basically, it asks the questions, are all the items on the left in the right? And also this returns a Boolean. Let's have a look at this. So we ask the list A, B, and C of the letters A, B, and C. Are these all in the array? And yes, they are. So it returns true. In this question, it basically asks the list A of the letters A, B, and E, are these in the array S? And this is false. Now, this actually allows the shortcut, because as soon as it realizes that the E is not in there, it can stop. It probably would have to go all the way to the end, but it would probably still be faster than actually creating a set for it. And there's lots and lots of other ones. This one is the union of. Simply, the simplest way to type that is parens open pipe parens close. And you can use the Unicode character for union for this as well. And basically, it creates a comment. Oh, what happened there? Oops. It's like real life, isn't it? Basically asks the question, it creates a combination of all the items on the left and the right. And it returns an appropriate QuantHash. So, we have an array 1, 2, 3, and we create sets of these and create a union of it, which creates a set with the values 1, 2, 3, 4, and 5. Even though 3 and 4 occur multiple times in the arrays. But of course, you don't actually have to coerce to these sets. You can actually just do this on the arrays and basically be faster that way. But you should notice that you should know that set operators are contagious. So what does it? I mean, okay, yes, I know we're Corona and everything, but no, this is not about that. This is about basically the semantics that you are going to get in the set operators that do not return booleans, that return QuantHashes. So you actually default to set semantics if no other QuantHashes are involved. But if other QuantHashes are involved, it uses the semantics of the least restricted QuantHash. And if you happen to use a mutable version of a QuantHash, then you will actually get a mutable result. So look at the code here. So the union of these two arrays is a set. That's because if there's no QuantHash involved, we will get a set. In this case, we actually used a coerced the B array to bag. And the result, therefore, will be a bag. Note that the D will be in there twice. And of course, it doesn't matter if it's on the left or the right. In any case, it's contagious. So if any site uses a bag, you will get a bag result. And if either side is actually a mutable version of something, you will get the mutable version. So if you actually use set hash on either side of these, you will get a set hash. Now, we've seen a few set operators now, but there are actually many of them. Whoa, that went quick. So basically, these are all the set operations that we have. That's a lot of them. So basically, the first line we already seen, the identity and the set equality. So let's go for the next one, which is I call the contains set operators. Basically, it's either is element of or is not an element of, and that's the Unicode code for that. Or you can actually reverse the parameters, and then it becomes contains with parens open cont, parens close, or does not contain. And you get the mathematical symbols for it as well that you can use in the Unicode. The sub and supersets. So we've seen the subset already, and we also have a Unicode version for not a subset. And we have the parameter reverse version, basically is a superset or is not a superset. In this case, the number of elements between the two sides may be equal. For proper sub and supersets, the proper subset is not a proper subset, and the reverse version thereof, the proper superset and the not a proper superset. And in this case, the number of elements may not be equal. So this is really taking the concept of a subset, basically not all of them, to the extreme. Mathematically speaking, some mathematicians say that subsets can have the same elements and call those proper subsets, and it's a bit of a mess, but in Raku we call these proper subsets. Then we have the union and intersection set operators. The union we've already talked about. The intersection basically looks at the items that creates a result of items that are at both sides of the set operator. Then we have the difference set operators. The asymmetric difference, basically what is not on the right side of the operator. And the symmetric difference, which is basically not on either side of the operator. And finally, we have the Baggy operators. The Baggy operators, basically, they either add weights or they multiply weights. And the result is always a bag or a mix. An element in an implicit set has a weight of 1, and non-existing elements have a weight of 0. So multiply weights can be used to actually root out elements from a set, because if you multiply something by 0, you will not, it will become 0 and therefore not become part of the result. Now, we have seen all these operators and it's all very nice and all very good, but there's actually some related functionality that we have in Raku that also use set semantics, but you may not realize it. So here we go. The related functionality. The unique method that you can call on anything that is iterable or basically returns all the unique elements in the order that they are in the object. We have squish. Squish returns all of the elements that are different from the previous element in order. And of course, we've already seen this a little bit. You can actually call the set method with a capital S to create a set of all the unique elements of the object in question. And you can call .bag to create a bag with a count of unique elements of the object you call this on. So let's go through some quick examples of all these operators. So here we have a range of 0 to 99, and we ask, does it contain 42? And the answer of that is true. In this case, we take the union of a range of 1 to 5 and 3 to 7, and the union of this is a set 1, 2, 3, 4, 5, 6, 7. Even though 3, 4, and 5 occur on either side, they only occur once in the result. This operator basically takes whatever are in both sides of the operator. So we actually get a set of 3, 4, and 5 because they are on the left in the range 1 to 5, and on the right they are in the range from 3 to 7. Now, if we look at the symmetric difference operator, again, we do this on the range from 1 to 5 and 3 to 7. We get a set of 1, 2, and 6, 7, because those are the values that are not in either side. And of course, we can actually take a list of values like 1, 2, 2, 2, 3, 4, 4, and ask for the unique values, and we get 1, 2, 3, 4. And we can actually have a list called with 1, 2, 2, 2, 3, 4, 2, and call squish on it, and we're going to get 1, 2, 3, 4, 2. Why the last 2? Because it's different from the 4 in front of it. So that's just a few examples. And if you really get used to all of these stuff, you can basically get very used to writing Raku and become very concise in doing stuff. So for instance, let's look at this little piece of code. We're basically creating we're taking a list of letters of A to Z, and then randomly take a letter out of that 1,000 times. That creates a list. Then we're actually going to bag it. So we get all of the letters in there and how many times they have occurred in this random sample. Then we're going to actually sort them by the negative value, which basically going to create a list of values in descending order. Because the bag can be considered a hash and sort basically sorts on the pairs, we actually ask it for the value. So star.value basically means take the value of each of the values that we get presented, and in this case, take the negative value of that, so we actually get it in descending order. And that list result, we only want to have the first 5 of them. And there you go. We want to say this so you can actually see it on the screen, and there we have the result. Now, of course, whenever you run this program, you will get different results because we actually randomly took 1,000 letters. So you get random results. But this should give you an idea of what you can do in Raku. So that's why I made this presentation, and that's why we're getting to the end. Now, normally at FOSDEM, I would actually be there to answer your questions. I'm afraid that's going to be impossible because of the corona restrictions. So hopefully next year we'll be able to see each other again, and we'll be able to give a proper presentation in real life. So when you have questions, basically you can look at the documentation of Raku, docs.raku.org. There is a section on Stack Overflow if you have more pertinent questions that you would like to ask. There's also a subreddit for Raku called Rakulang. Because Raku is also a form of pottery, and there's lots and lots of people that already use the Raku tag on social media, we have decided to use the Rakulang tag for social media. You can also chat on our Raku channel on Freenode. Not a lot of people doing Raku pottery on Freenode, so therefore we can actually have the Raku channel there. And of course, if you want to ask questions, you can tag your tweets with Rakulang, and people will see it. And if you have questions or anything to note regarding to Raku, you're welcome to put this tag into your tweets. Other useful links: the main site for Raku, raku.org, the ecosystem, modules.raku.org. It basically allows you to see what modules there are available for the Raku programming language. There's a weekly blog called the Rakudo Weekly Blog. So on Monday, that could be in the afternoon European time. It could be later. It could also be a Tuesday. And every now and then, maybe once a year or so, we'll skip a week. But generally on the Monday evening, you will get a new issue of the Rakudo Weekly News. There's Comma. That's an integrated development environment created by Jonathan Worthington and friends. It's a very good IDE if you really are used to using IDEs. It's based on the IntelliJ platform, and it's really worthwhile if you're into that kind of thing. Also, very nice set of programs that you can use is Crow. It's a toolkit for creating web services, and it's very versatile and very handy, and it's used in production, so it should be good. And we have an RSS feed collector called planet.raku.org that basically if you're writing a blog and you want to automatically have your blog appear in the RSS feed on that site, you can actually have it added there. And it will show up whenever you make a blog post. So that's basically what I had to say. Thank you very much. Thank you for watching. Thank you for staying all the way to the end, and hope to see you next year for a real FOSDEM. Thank you.